Hey guys, just to let you know that you can catch these lessons live every Thursday from 6 PM until 7 PM UK or BST time, and that will just allow you to ask any questions that you want and get some answers to them. Without further ado, let's get on with the lesson. Okay, welcome to the third, I think, A-level lesson that we're going to be doing. Today we're going to be covering binomial expansion. So binomial expansion is somewhat tricky topic because you can do the whole thing on a calculator. So on that part it's kind of easy. The downside is that it's very easy to make a mistake as well. So let's go through what binomial expansion is. So when we expand brackets, right? So let's say we have x plus 1 to the power of 2. Okay, then all we do is we do x plus 1, multiply them out, we get x times x is x squared. Then in the middle we'll get a plus 2x. And at the end we'll get a plus 1, right? Cool. Now what about if we had x plus 1 cubed? Okay, this gets a bit longer. So x plus 1, and then I won't skip ahead. Let's actually do it the whole way. You would expand two of the brackets. So this one, which would give you x squared plus 2x plus 1. And then you'd also get x plus 1 again. Okay, then you're going to expand it one more time. So x cubed plus x squared plus 2x squared plus 2x plus x plus 1. Then you'd gather the like terms. You have x cubed plus 3x squared plus 3x plus 1. So as you can see, it's taking a bit more effort, right? So what we need to do is find an easier way to do this. Now, can you imagine if we had to do x plus 1 to the 4? Okay, what about x plus 1 to the 10? So that's getting a bit tricky, right? But you might notice that you have these patterns coming up. So the number in front of x squared here is 1. Then the number in front of x is 2. It's 1, okay. And then you have 1, 3, 3, 1. And when you did x plus 1 to the 4, you can get certain numbers as well, which I'll show you in a second. Now we can actually work out what these numbers are by using something called Pascal's Triangle. And it's really easy to write this out. You start with the 1, and then below it you put two more 1s. Then you're going to go out one more, and you're going to write 1 and a 1. And what you do is you add these two numbers to work out what this middle number is. So 1, 3, 1. Then once again you draw 1s on the outside. 1 plus 3 gives me 4. 3 plus 1 gives me 4, so you have 1, 4, 4, 1. Okay, and you can keep following this to basically create what the numbers are going to be in front of this. So this would be for when the power is 0, obviously it's just going to be 1. Then when the power is 1, we just get 1 and 1, right? Because what you would get is you'd get x plus 1 to the power of 1 is just x plus 1. So the numbers in front of these are 1 and 1. Then n equals 2, we get 1, 3, 1, and so on. Now, as you can imagine, if we're doing x to the power of 10, we have to go 11 rows deep. That's pretty tricky, right? Like if we kept going, it'd be longer and longer and longer, and we'd get some ridiculously long row. And obviously, if you're in an exam and they ask you to expand x plus 1 to the power of 10, you don't want to do that. Okay? So instead, there is something else that we can do. Okay? And there is a button on your calculator that says NCR. Now, if you have the Casio calculator, which is recommended that you use, which is the FX991EX, which is this calculator here, can you see the button? It's actually above the divide sign where it says NCR. To get it, you have to press Shift and then the NCR button. Now this button does something very, very interesting. So I want you to keep an eye on this line over here. Okay, so the N part of the NCR is the power of the bracket. So in this case, if you look at the cubed, the power is always 3. Okay, and the R is what place you are. So are you looking at the first term, the second term, the third term, the fourth term? But, and if you're doing computer science, you might recognize this, counting starts from 0. 1 isn't the first one. So just to reiterate, n is the power of the bracket. And R is the position you're in. Okay. And it starts from 0. Okay? So when I type this in, it's going to give me the number that is in front of the first term, which is 1. That's correct. Then what I do is I change this to 1. I'm looking for the second term. It's 3. Then I look for the third term. It's 3. And the fourth term is 1. 1, 3, 3, 1, which is exactly what we get here. So now, all I need to do is change the power of x. Can you see that? Okay, so if I go back to 0, I can write that as 1 times x cubed. Then go to the next one along. Plus 3, and then all I do is I reduce the power of x. And make that 2. Again, 3, and then reduce the power of x, and then plus 1. Okay. So if I were to do x plus 1 to the power of 10, this is what I would do. I would get my calculator. Now, n is the first number. We change that to a 10 because I'm looking at the power of 10. And the first digit is represented by 0. Press equals, and I get 1. Okay? So I'd write 1. And then x is always to the power. We start off with the power of the bracket. X to the 10. Then what I do is I change this to a 1. And I get 10. So what I do is I do plus 10. And I reduce the power of x by 1. And then I go along again. And I do 2. You get 45. And if you wanted to look up the answer, you'd find that this is indeed correct. And I reduce the power again. And then plus ... Okay. Now, the trick is here is that in the exam, they won't ask you to write out the whole thing. Okay? They'll ask you for the first 3 terms or 4 terms, or you just have to do a few terms. They won't ever ask you to do 10, 11 terms. Okay? But if you were to look up what the expansion of x plus 1 to the 10 is, you would get these 3 terms at the beginning. So that's pretty damn useful, right? Instead of having to expand more and more brackets, or instead of having to use Pascal's Triangle, I can just use the NCR button. Now, there is a small caveat. Okay, it's not just this simple. What if this wasn't a 1, but instead was a 3? This is where things get more interesting. Okay, let's say we're doing x plus 3 to the power of 10. Well, again, I'd use the NCR button. So these numbers will stay the same. That's fine. The power of x will also stay the same. But now you're probably getting a bit suspicious. How can everything be the same? Well, technically speaking, this number on the end here also goes in a bracket. But it starts off at power of 0, which does nothing. And you increase this power while this power goes down. So I said x to the 9 here. Now it's going to be 3 to the power of 1. So that should actually be a 3. But in this case, it was a 1. So it'd be 10 times 3. And then 45 x to the power of 8. So I've reduced the power again. So I increase the power again. So instead, my answer is now going to be, again, it's still x to the 10. But now it's going to be 30x to the 9. And 3 times 45 would give me 115. Not bad. So 45 times 3 would be 135, sorry. X to the 8. Okay? So if this number isn't the same, all you need to do is make sure you're increasing the power of the number while decreasing the power of x. And now you might also ask, well, what if it was a 2x? Not 2x, just by itself, obviously. Plus 3 to the power of 10. Well, then, you're still going to have the numbers in front. But then, instead of x to the 10, it becomes 3x to the 10. So then you need to do 3 to the power of 10. Okay. So, I hope that that is okay. And you're okay with that. So, that would be how you would do that one. Okay. So now when we go to the questions, let's just do a bunch of examples because this is the best way to learn in my opinion. They sometimes word it in ascending powers. So first three terms in ascending, you're going to have your constant, so like a 1, then you're going to have x and then x squared. That's what ascending powers means. Okay? So instead of doing it this way, where we've done the highest power and we've gone down, we need to go backwards. Now going backwards is not that tricky. Okay? So what we're going to do here is we're going to use the NCR button once again. Okay? So what is the NCR button when we have the power of 6? So here, change this to a power of 6. The first digit, is going to be a 1. So I'm going to put a 1. Now with ascending powers, the constant goes here and it has the highest power. Okay, so technically that means x over 2 is to the power of 0. Okay, so it's just literally the inverse of what we did up here. Where we went down with x, up with the number, we're going down with the number, up with x. It's fine, because it's the ascending powers, okay? Then plus, and let's bring our calculator back. What would the second term be? So again, even though it's a 1, it's the second term, because we start counting at 0. 6, so we're going to write 6. And remember what we do. Reduce the power of the 2, so from 6 we're going to 5, and increase the power of this, so x over 2 to the power of 1. Okay, good. Now bring back my calculator. Now we're going for the third term, which is represented by 2, 15. So 15. 2, again, reduce the power of the 2 to make it 4. Increase the power of the x to make squared. Now let's expand this. What is anything to the power of 0? It's 1. So we have 1 times 2 to the power of 6. So guess what I'm going to do? I'm just going to use a calculator. You don't have to do the whole thing. 2 to the power of 6. Enter the exact same thing. And you'll never get it wrong. Equals 64. Wonderful. So that whole thing equals 64. Plus, now look, I'm not going to rewrite the whole thing. Use the arrow keys to edit what your thing was. So I change that to a 6. I change the power to a 5. And now what's the actual value inside here? Well, it's 1 over 2. So I'm going to leave the 1 over 2 there. 96. And then remember that there's going to be an x. And again, I'm not going to change anything. I'm going to press the right arrow, go here. It's 15 now. Instead of 5, it's 4. And instead of the power of 1, I'm going to put the power of 2. 60. That is your number in front of the x squared. That's it. That is 4 marks. 4 marks? I did the whole thing on a calculator. How much brain power did I use? All I have to do is remember, reduce this power, increase this power. Reduce this power, increase this power. That's it. It is mind-numbing how easy that is. Okay? It's really not that tricky at all. Now the tricky bit is, doing part B. But part A, which is 4 marks, 2/3 of the marks of the question, is that simple. Okay? So let's go down. It then says, using your expansion, find an estimate for the value of 2.05 times 10 to the power of 6. So, if you notice, this power here is going to be the same as this power here. Always. Okay? So what they're saying is we have the expansion for this. Right? And I want the expansion for this. So what I want to do is I want to know, what do I sub in for x in order to get the estimate? And what we do here is we work out what x is. So the first thing I do is I take the... That was a horrific... I'm taking the 6th root of both sides, which gives me 2 plus x over 2 equals 2.05. Subtract 2 from both sides, I get x over 2 equals 0.05. Times both sides by 2, I get x is equal to 0.1. So all I need to do now to find out an estimate for what 2.05 to the power of 6 is I sub in x equals 0.1. Now keep in mind there is an A2 version / year 13 version of binomial expansion. So this only works, so this method here is for positive integers, okay? So it's for so where n is a positive integer, so a natural number. So what you'll find is next year or later on, we're going to deal with n when it's a negative integer or a fraction or a fractional negative integer. And you still have to do the kind of find an estimate for. That is a key part of this topic. So just for those of you that might be curious as to where these binomial expansions come from, we use them to find estimates because sometimes there are math expressions that are too complicated for us to work out using computers, and obviously we can't do it by hand. So instead we use binomial expansions to approximate and estimate the answer. Okay? Because if we keep going in this expansion, x becomes smaller and smaller and smaller, right? Because at first x is 0.1. What about 0.1 squared? That's 0.01. Then cubed, 0.0001. To the power of 4, 0.00001. As you can see, it's getting smaller and smaller and smaller, which means we're actually getting closer and closer to an answer which is actually pretty damn good. Okay, so if any of you do physics or maths at university, you'll be using binomial expansions a lot. Then all we do is, using our calculator, we sub in exactly what it says. 64 plus 96 plus 60 and I get 74.2. Okay. Now what we can do is actually see how good this estimate is, and this is actually again something that'll come up later, is you'll have to work out as a percentage how good your estimation is. That's pretty good, right? We're off by 2/100ths. So if we went again, we would get closer and so on. Okay, so that's one example. Hope that's all okay. So obviously the next thing we can do is just keep going through more questions. And yeah, this gets a bit more interesting. Okay, but the first question is still 4 marks and it's still relatively easy. Okay, so what we're going to do once again is use our fancy MCR button. Okay, so for A, once again, we're going to do Shift N. On the left hand side is our power, which is 7. Right hand side is what position we're in. So at the moment we're in the first position, which is 0, so we're going to do 1, 2 to the power of 7, and I'm going to keep writing the minus, like the other bits, these bits here. I'm going to keep writing it even though you don't need to. Okay, don't need to. And then that'll be plus. And then what is the value going to be? 7. Oh, that's handy. Reduce the power of the 2 and increase the power of the x. And it says first 3 terms, so we go one more term. (21). Reduce the power of the 2. Increase the power of this. Cool. Do you remember what the next step was? Just subbing in exactly what it says, right? So let's do that. In fact, I'm going to be really pedantic. I'm going to put exactly what it says in. So 1, 2, the power of 7. You don't need to put the x. Minus 1/8 to the power of 0. 128. I'm using absolutely no brain power right now. Okay. Now I'm not going to put a plus or minus because I can see there's minuses now, so it might change. Change that to a 1. Change that to a 6. Change that to a 7. See? Bear in mind, 4 marks means it should take you 4 minutes to do this. But how long is it actually taking me to do it? Bearing in mind, I'm actually doing this. I've got a bit of a handicap because I'm clicking to type this in. If I was doing this by hand, I can use both my hands at the same time instead of just using one hand like a peasant. 21 over 2. I'm done. That's it, 4 marks. Probably the easiest 4 marks you'll get, but you need to make sure you're doing it right. Enter it exactly on your calculator. You cannot make a mistake. It's impossible. I dare you to make a mistake. Okay? So, let's have a look-see. They tell me that we have f of x equals 7. Okay. Cool. And what they're asking us to do here is, given that the first two terms are 384 and minus 104x, find the values of a and b. So what you need to do here is you need to expand this bracket. So if you have a look, we've already got this kind of expansion, right? Now what we can do here is replace the second bracket with what we've just worked out. Okay, so all I've done is just replaced it, so make sure you're okay with that. Okay, it then tells me the first two terms. So we're going to have x to the 0, or a constant, plus x to the 1. That's the only terms I care about. Okay, so when I expand this, I don't need to fully expand it. If you get ax cubed, that's pointless. We only care about the numbers, i.e. the constants, and anything with an x. So I'm going to do ax times 128. Now, do I times ax by anything else? No, because if I times it by x, I'd get ax squared. I don't need x squared. If I times it by x squared, I get x cubed. I don't need x cubed. So I only need the first term. So, okay, cool. Now, b times 128, okay, that's fine. And then minus 56 bx. Do I times it by the last thing? No, because then I get x squared. I only care about these two bits. So again, you wouldn't be wrong if you fully expanded it. But there are two issues. One, it's a waste of time. This is half as many terms as I should get. I should get 6. 2, you'll get confused. I now know that everything I have here is useful. If you expand it, half your stuff is not useful, and you'll sit there thinking, oh my god, what do I do? So, it's telling me that the first two terms are 384 minus 104x. So from here, you might see what we need to do. Okay, what we're going to be doing is equating x to the 0 terms and equating x to the 1 terms separately. So let's start. If we start with x to the 0, x to the 0 in this is just 384. Make that a colon actually. And what is it in this term? It's just 128b. So in other words, b equals 384 over 128. Okay? So again, like, don't risk it. Like, even if it is basic maths, just do 384. See? Use a calculator. Now equate the x1 terms. We have minus 104. You don't need to put the x's, but I will put the x's just so you guys are clear. 128 ax minus 56 bx. Now if you notice, I can divide this through by x. That's why you don't need to write it. I can also sub in for this. B is 3. So in other words, I have minus 104 equals 128a. And again, let's use our calculator. What is minus 50? Whoops. What's minus 56 times 3? Minus 168. So plus 168 to both sides. We get 64. Or again, you can just use a calculator. I'm being lazy even with a calculator in front of me, which is kind of funny. 64 equals 128a. Divide both sides by 128. Again, you probably know what the answer is already, but I'm going to use a calculator just to make a point. Okay? A half. And that there is also 4 marks. Okay? Which I don't think is too bad once you know what you're doing. The issue is knowing what you're doing. Okay. Any issues with that? Okay. Let's go to the next one then. This next one is a bit of a pain in the backside because we have to fully expand it, which is kind of annoying. But I'll show you it's actually not that bad. Okay, so once again, we're going to use our trusty calculator. NCR button. The power is 5. We're starting from the first place. So this is actually interesting. These aren't numbers, so technically I don't need to do the power thing. So like it'd be 1 p to the 5 q to the 0 plus, and then so on. So you don't need to do it, but I'll do it just to kind of make a point. Oh, great, typically I'll make a mistake immediately. P to the 4. Again, just reduce one power, increase the other power. Plus 10 p cubed q squared. I have a lot of trouble writing q's, I don't know why. Again, another 10. And if you notice, they're always kind of palindromes, right? They're the same forwards as backwards, which is, and I won't say it's interesting, but it's something. That's it, finally. Whew. So a bit tedious, but not hard. In fact, I got a bit bored during it, and I'm sure you did too. So if you want, I'll write this out like properly, so to speak. So oh, one day I won't be stupid. There we are, and then plus. There we are. So it then says, using the last 2 terms of the binomial expansion or otherwise. So we're basically given a probability of Dave being late is 0.1, and let P represent the probability. They've actually done a lot of work for us, believe it or not. Using the last two terms of the expansion, find the probability that Dave is late no more than one time in a week. So P is late. Okay, so if I have a look at this, right, if you remember your probability, right, the probability of him being late once is 0.1. The probability of him being late and then late again would be 0.1 times 0.1. Or in this case, it would be P and then P times P, so P squared. Yeah, and so on and so forth. Okay, so for him to be late no more than one time, he's either not late, right? Or well, in this case, it'd be late or late, right? So if I have a look at this, I'm looking for the terms where there are no P's, because he's not late at all. So that's this term. Or there's only one P, which is this term. That's it. That's why they gave you this hint using the last two terms of the binomial expansion. Okay? Because in this one here, he's late twice, early 3 times, late, and then so on. I hope that makes sense, because when we come to statistics, it's going to be... we have binomial distributions and things like that where this can somewhat come in, so it's kind of useful to know. So if P is 0.1, the probability he's late is 0.1, then the probability he's not late has to be 0.9, because probabilities add to 1. Okay. So now we're just using the last two terms, so it'd be 5, P is 0.1, Q is 0.9. And again, I'm going to use a calculator. So again, just because, so some kind of, actually 0.91854. Cool. So that's 7 marks. We did that very quickly, even though I was explaining it to you. And it really wasn't that bad. It's just they try and trip you up using the second part. So as you may be aware, at least 10% of your marks have to be something called unseen marks, which basically means they have to give you a situation you haven't seen before, but it's the same maths. This is one of those parts. Generally speaking, the last part of any question is going to be this unseen stuff. So you may never, well, the people who did this exam first would never have seen a question like this. They would have had to do it themselves, like think on the spot. Okay? So your goal by the end of A-levels is to be able to think on the spot. Okay, and be able to kind of pick apart these questions quite easily by yourself. Okay, so practicing them is really, really important. But yeah, so 10% has to be unseen. The reason for that is if 10% wasn't unseen, you could just learn mark schemes to get basically 100% in your exam. So they put these 10% marks in to say that, you know, it kind of separates the people that are really good at maths and understand it versus the people that are just really good at studying maths. So yeah. They also put this P plus Q to the 5 in. It doesn't change anything. The first thing's there and the second thing's there and you change it. Normally this is a number and an X. But what are P and Q? Well, they're just numbers. We don't know yet. So they work exactly the same. Even if they use like theta and delta, still letters, doesn't matter. Okay. Anyone have any questions about that? Good to hear. Let's go to the next question then. So up to and including x to the power of 3 would be the first 4 terms. Okay. So once again, I'm just gonna play, and we're going to do our NCR button. Shift NCR. The power is 8. and the first position is 0. Please, please, please remember it's 0. Basically, in your binomial expansion, your first coefficient is always 1. Okay, and we're going in ascending order, so we want 1 to the power of 8. And then again, you don't need to write this part, but I'm going to keep writing it just to make sure you are aware it's there. And it's easier to not forget either. 8. Again, you might be noticing patterns in what the numbers are as well. That's good. You can use that to help verify and check you're doing it right. Still use a calculator, but check that it's right. Check it makes sense. If something doesn't make sense, you want to re-look at it. Again, reducing the power of the 1, increasing the power of the 4x. And the power should add up to this power here, right? And we're up to x squared, so we need to do 1 more. 56. Okay, so again, it's tedious, boring, but to be fair, if you find this tedious, then you'll really enjoy the A2 binomial expansion, where you have to do it kind of without a calculator, so just keep that in mind. Again, I'm going to type in exactly what we're doing. That's 1. I'm absolutely shocked that that's 1. Again, you can do this a lot quicker on your calculator by hand. And always remember the x's as well. Don't forget that, because that's not on your calculator. Although in some calculators you can actually put x's in and everything, which is nice. Hopefully you can see how powerful this tool actually is. Or for those of you that are just doing math to get into your degree option, then you probably don't care, but good. 3,584. There we are. Done. And once again, show that you can get an approximation. Okay, cool. So again, with the approximations, this is actually going to be really accurate because it goes up to x cubed. Generally speaking, in maths and physics, we only go up to x squared, sometimes x cubed. We don't even go further than that. So we're actually getting really accurate answers. But let's have a look. Again, this expansion is for this thing here. So we have 1 plus 4x, 8. And we want to work out what we need for x to be in order to get an approximation. So again, we're taking the 8th root this time. So that'd be 1 plus 4x equals 1.04. Subtract 1. 4x equals 0.04. Divide by 4. X equals 0.01. So if we want to do that over here, our approximation for 0.04 approximately equal to 1 plus 32 times 0.1 plus 448 0.1 squared plus 3,584. Which again, let's just type it into our calculator. So this whole topic, really, it's use your calculator, but then you also need to use your brain to apply it to situations. So generally speaking, students find these to be 3 marks, okay, because they find it really easy. And they say that once they've done a bunch of practice questions at home when they're nice and comfy. But guess what happens every single time they go into an exam? They make mistakes. Okay, so they'll not sub in the right thing onto their calculator. They'll not do some other random thing. Speaking of mistakes, I made a mistake. I subbed in 0.1 instead of 0.01. See? So even though it's boring and tedious, you can quite easily make mistakes like I just did. Okay? And I'm wondering how many of you watching noticed I made a mistake and how quickly you noticed. Because that's kind of exactly how your brain will be, right? And it gives you 1 point, and it says to 5 significant figures. So we're going to go up to that second 3. So 1.3684. Okay, easy to make a mistake. Okay, again, I'm wondering how many of you actually managed to spot that I made a mistake. You know, because I intentionally did it, of course. But very easy to make a mistake, and as a result, students go in saying binomial expansion's easy. I don't need to practice it, and yeah, it's easy. But when you're in an exam, you're under a hell of a lot of pressure, right? So your end of year mocks or your end of year actual exams, if you're in year 12 or 13, it's very easy to make a mistake. So writing it out exactly as I have, it's longer, sure, but it can really guarantee you won't make mistakes. Okay, so just be very conscious of that and how easy it is to mess something up. Okay. Okay, that's enough lecturing. Let's go on to the next question. So again, as you can see, there are actually different styles of questions. So this is the other style of question you can get, which is where they'll basically ask you to they'll put like an unknown variable other than x, and they'll give you what the coefficient of one term is, and they'll say, okay, find the value. Okay, very, very, very common. If you look through any past papers, this is the most common, so most common style of question. Okay, so like we did before where we had A and B, I believe it was, that's also extremely common as well. So it's like there's an unknown variable. It's the most likely one to come up, okay? So get good. First 4 terms, which means x cubed, right? Of the expansion 2 plus kx. 5, 6. Okay, let's do this. Once again, what is the power? The power is 6. What position am I in at the moment? I'm in position 0. And it's a 1. I'm absolutely shocked. And it's ascending power. Okay? Which means we're starting with 2 to the power of 6, kx to the power of 0. Do that to 1, 6. Again, it's the first 4 terms. That's another thing, by the way. Normally, they say the first 3 terms. Okay? So I've seen students, in questions where it says list the first 4 terms, only do 3 terms, which means you lose an entire mark. So just like be very conscious of it. So that is a 5, by the way. 2 and then reduce the power 4. So what I like to do is when I read the first 4 terms, if you notice, I immediately wrote x cubed, right? So that's in mind. Also, we're lucky. It gave us the coefficient of x cubed. So if you only did 3 terms and you saw it said x cubed, you'd probably be reminded that you need to change to question A. But normally they give like x squared or the x term, in which case you're kind of screwed if they if you made a mistake in the first part. Wait, did I just do this one? Yeah, I did. So 0, 1, 2. Okay, so now you might be wondering, what do I enter in my calculator because I have k's? Well, I never bothered writing the k's and the x's, so if it's a k, I also don't bother writing those. What I'm going to do instead is just literally write. It actually makes my life a bit easier to enter this in. So that's going to be 64 plus, change that to a 5, so 32, and then kx, don't forget. We get 16. And now it's going to be k squared x squared, bear in mind. And then lastly, cubed k cubed x cubed. So again, remembering the powers is probably something that may trip you up. And so that's just working out the powers of 2. So if we were to work out the actual values here, so again, I'm just working out the powers of 2 initially. So to work out the full powers, you do that. So this would be like 192, for example. So 64. Okay. So it can help to kind of break it down into doing the separate bits separate. But it's completely up to you what you want to choose. $160. Okay. Then for part B, so again, this is 4 marks. Pretty dang good in my opinion. Not much work, but it does require a bit of concentration, which again can be lapsing, especially in an exam. Part B, the coefficient of the x cubed term is minus 20. So what we have here is, if we look at the x cubed terms, we have 160 k cubed x cubed equals 120. But it says coefficient, so we get rid of x cubed. Coefficient is the number in front of x. So fairly easy. K cubed is just equal to 120 over 160. So k is therefore equal to, so it's actually negative 20, isn't it? Whoops. The cube root of negative 20 over 160. And all you do is calculate that value. Okay, so again, we can negative a half. And that's our answer. Not too shabby at all. Give a second just to have a think about that, make sure it's okay. Okay. Okay, so let's do another one. So again, this is another style of question they can ask you. Again, it's fairly similar to what we've done before. But let's have a look-see. Just so you're aware, I'm actually going to start uploading shorter summaries of lessons, because I think these long lessons can be a bit tedious for some of you. So there'll be 5 minutes ideally where we literally summarize the chapter, so give you like the individual equations, and then there'll be a link saying if you want to watch more, then you can go here to find exam question practice, okay? But that is the plan for the future. But let's start with this. So again, find the first 3 terms in descending power of x, blah, blah, blah. Okay, cool. So NCR button again. So the power is 5, and the position is 0. It's 1, shockingly. So we have 1 to the power of 5, minus 2x, power of 0, plus 5 1 to the power of 4 now because we reduced the power, minus 2x to the power of 1. And it's the first 3 terms, so we're going up to x squared. That's 10. 1 to the power of 3 minus 2x to the power of 2. Cool. Now all we need to do is actually sub in this stuff into our calculator. So we have 1 to the power 5 that makes 1. Absolutely shocked at that. That's actually not going to be a plus this time, is it? So what we do is go from left to right, change that to a 5, reduce that power, increase this power, minus 10, x, cubed, (40) x squared. Okay, and then it says, so find the first year of this thing here. First 3 terms again. Now, we should note that that means it's going to include x to the 0, x to the 1, x squared. So what we're going to do first is sub in our expansion that we just did, which is 1 minus 10x minus 40x squared. And then we're going to expand these brackets, but only going up to a maximum of x squared. That's the key part that students sometimes get wrong. So this 1 is going to times everything in that bracket. So we have 1 times 1 minus 10x minus plus even 40x squared. Then the x is only going to times the first 2 things, because the third thing will make it x cubed. So we have plus x minus 10x squared. Now simplify. 1 minus 10x plus x gives me minus 9x. Plus 40x squared minus 10x squared gives me plus 30x squared. I'm done. Bonus 3 marks in not too long, I think. Okay. So yeah, again with these lessons, it's good for you to join in live, because that way you get to ask the questions that you want, you get to suggest topics and everything like that. But it can also be good to see me work through them live. Obviously the lessons are kind of edited and they're updated, uploaded again afterwards, so you can kind of watch it in your own time. But with binomial expansion especially, it's a lot of practice. Okay, so and also having kind of a correct format, so a correct layout, is really important as well. So if any of you have any questions, then please let me know while you're doing the live stream. But I will be uploading shorter summaries, which will then link back to this as well. But is there anyone in the chat that is stuck or doesn't understand this? If not, I will do another question before we finish. Okay, let's do another one then. So, again, don't be afraid, don't be kind of weirded out by the fact that the marks look a bit weird. This is actually from the old spec, but keep in mind the old spec still has all of the same stuff in it. If you look, this question looks exactly like our other questions, right? So let's do it. Find the first 4 terms, so that means we're going up to x cubed of this expansion. So what we do is use the NCR button to work out what our coefficients are. So n is always the power of the bracket, which is 7, and r is where we are in the expression. So the first place is always 0. So that gives me 1. So I write 1. Then what I do is I write, since it's ascending, I'm going to look at the 2 first. So 2 to the power of 7, and then kx to the power of 0. Okay. Then I'm in the second place, so I put this as a 1, and I get 7. So now I get plus 7, and what I do is I reduce the power of the 2, so instead of 7, I make it 6, and I increase the power of the x. And that's all you do. That's rinse and repeat until the end, okay? So once again, change this to a 2 because we want the third position. 21. Reduce the power of the 2 to 5. Increase the power of the x. What do you do for the next one? Well, use the NCR button to find out what we're doing. That's 35. And then I reduce the power of the 2. Increase the power of the x. It is that simple. You could go on and expand the whole bracket if you wanted to. That's as easy as it is. Okay? But now we need to actually work out what these values are. And this is where some students mess up. So I write the exact thing it says here. So 1. And normally I would actually include the bracket of the x in it. But because we have a k, which is an unknown, I'm not going to do that. So the first thing is 128. Plus. And what I do is I change the number in front, 7. The end. 448. Now it's kx. Again, I probably did that the wrong way around, but that's totally fine. Again, if there was a number in front of x, I would also add that bracket on at the end, like I'd done in the previous questions. But in this case, it doesn't really make much sense to. And again, you need to be really good at this because there is a A2 variant of this, which is a bit more painful. Yeah, I'm just looking at this. And that, my friends, is probably the easiest 4 marks you can get. Okay? In an A-level paper. Part B, it tells me that the coefficient means the number in front, so all of this equals 1890. So in other words, 560 k cubed equals 1890. Now divide both sides by 560. Always divide by the thing in front first. You get k cubed equals 1890 over 560. Then you cube root both sides and you get k is the awful looking cube root of 1890 over 560. Guess what I'm putting into my calculator? The exact thing. So shift, cube root, fraction, three over 2. That is 7 marks. You can do it in about 3-4 minutes. And honestly, it's not tricky. It's easy to make a mistake. So, if there are no questions, then I will end it there because we're practically on time to finish. But again, we've done quite a few questions today. And again, if you want to go back and kind of pause and like look through the answers and do them yourself and everything, that might be a good thing to do. But if there are no other questions, then I wish you all a very good evening and I'll see you next week.